So again, great to be here. I'm Praveen Penmetsa. I'm the CEO and founder of Monarch Tractor. But just for today's session, if you're hoping to hear me talk about technology, I'm going to disappoint you. I will not be. If you're hoping to hear me talk about Monarch Tractor also, I'm not going to be talking about that. So I'm going to take advantage of the diverse group that we have here, from legislators to OEMs to farmers to technology companies, and kind of give a perspective of what we are seeing out in the world. So last week I was in India with all of the trade tariffs and all of that happening on. There's a perspective there. For the last 6 months, I've spent a lot of time in China talking to automotive OEMs who are now entering ag equipment for a change. Spent a lot of time talking to the Chinese legislators about how they are viewing food security and what they're going to do about it and what their plans are. So we'll be sharing some of those perspectives. Also on the technology side, have talked to a fair number of OEMs, and also we'll be sharing some of our own experiences. So you'll probably hear the word autonomy maybe once or twice. The rest of it is going to be something else. So with that, let's get started. So again, something that I often get asked is this word autonomy gets thrown around. Started off in autonomy in 2003 on a DARPA robot project. Was a part of the DARPA Grand Challenge in 2005. Worked in on-road autonomy for close to 10 years. Super thrilled to see that some of that technology has now hit the real roads, and you can actually get a ride and use that technology after 15 plus years of investment and development. Very often people still come to me and say, hey, autonomy is now working on the roads, why is it not working on the tractors and farming and everything else? And there's a huge difference, right? It's point-to-point mobility of people and goods is very different to what all of us know is very challenging in the off-road environment, and also in farming, where it's more about, it's messy, it's unstructured, it's dynamic environments. It's constantly changing, dynamic, right? It's very messy, it's unstructured, there's no maps, etc. So this makes it very challenging. But somehow, we all still talk about autonomy in terms of vehicles and point A to point B. When the farmers or the construction site owners could care less. They really don't care how much data we collected, what our path planning algorithms look like, et cetera, right? They're trying to get a job done. What is the unit economics on getting that job done? What is the quality, efficiency, dollars and cents? So with that in mind, what we went through at Monarch was we had developed one of the first all-electric smart autonomous tractors that is commercially available. We started the company in 2018. We launched this tractor in 2024, started off in the vineyard space with this tractor. And then expanded to the dairy space with that same hardware. And a lot of people said, dairy farmers and vineyard farmers do not buy the same equipment, Praveen. What the hell are you trying to do? Our second largest market today is the dairy market. We have close to 100 customers in dairy using our tractor. And the reason that is possible is because the value proposition is not on the hardware side, it's on the software side, it's on the what operation the tractor is doing, it's not what does the tractor look like. We then expanded to solar. By the way, we went into dairy. It took us roughly, from the time we sold our first tractor to a dairy farmer to us deploying autonomy, took us close to 18 months. We went into the solar industry, again, doing the same thing, same tractor. They were not using this tractor, and they were like, how is this going to happen? Took us 6 months to collect data, train data, and now we're deploying solar autonomy for the largest solar utility company in North America. How can they use our tractor? It's across 14 sites. We are also in a lot of other spaces. So the key takeaway here is each one of these is very diverse, messy, but also the biggest problem that we have is fragmented use cases. There are 400 plus OEMs in ag and construction globally, 400 plus OEMs. And the reason they're all there is because they all have insights with their geographies, with their crops, with their operations. They're really good at it. 400 plus OEMs, right? It's nothing like on-road. So the key here is not just the technology side, AI, et cetera, but it's also the second term that is super important is software-defined vehicles. Because the reason we were able to go with the same hardware into 4 different industries and more is because we built the first software, completely 100% software-defined vehicle. We completely changed what the vehicle can do just with software. And the reason this is very important is, as all of us know, because of all the fragmented use cases, autonomy in agriculture and off-road environments is not just about technology, it's about number 2, data. And the more data that we collect from the field, the more we learn about how the operation needs to happen. And number 3 is deployment. The only way to collect that data is you have to go out into the field and collect that data. That comes from deployment. We have teams in 4 different continents walking people through collecting data on like how that same operation happens. I've seen dairy farm feed pushing in a number of different states in North America. Just yesterday, we were walking a dairy farm in Saudi Arabia on how do you do dairy feed pushing in Saudi Arabia. Slightly different, right? So unless you deploy to all these areas and collect data, you will not be able to train your models. At the end of the day, your model is as good as your training data. It's very easy to get super focused, right? So that's the key there. And that's where software-defined vehicles coupled to data and deployment is key for us to enable things like autonomy in farming. When people say, why is autonomy not ready in farming? It's because the amount of data that we have to collect and the amount of deployments that we have to do is very high. Because even the 2 neighboring farms here might have the same crop, same soil, same operation, same equipment. They'll do it a little bit differently. How do you know that? We have to go there, deploy, collect data, make adjustments. So one of the key tenets for Monarch when we started the company was not just about autonomy and data, which we touched upon. It was also about decarbonization, right? What we call DAD, right? Digitization, automation, and decarbonization, all 3 of them go together. And the reason is nothing to do with policy or sustainability philosophy. It is all to do with efficiency. Every work vehicle, we believe, has to talk about efficiency, right? When we talk about our tractor, we don't talk about it being electric. We talk about the electric nature saving $7 an hour compared to a normal diesel tractor. $7 an hour, right? It's not, it's a big number. Half the cost of the driver very often. So all these 3 go together. And this is, again, where when we talk to OEMs in Asia, they are now talking about leapfrogging to the next generation of farm equipment, what they call future energy equipment, where they see more solar coming on to rural areas. They see more solar on farms. They want to make farms self-sufficient from an energy standpoint. We heard about how important the energy side of the equation is in the morning. So that's their perspective is farm equipment is going to be a combination of electric, hybrid, and yes, some diesel equipment. It's going to be all 3. And they're already working on the next generation of equipment. And we have seen this play out in the past as well is when we looked at drones, right? Drones were essentially something that we all invented here in the US. The drone industry began here. But somehow, the last 20 plus years, we have lost control of that industry in terms of where the sensors come from, where the electrification comes from, where the motors come from. All of that technology has now been leapfrogged into other parts of the world. I can see the same scenario now playing out when it comes to farm equipment, because they are making those investments. They are saying we're going to invest heavily into next generation future energy farm equipment, because that's where the efficiencies are. It's not a philosophical argument, it's an energy efficiency argument. So every work vehicle needs to evolve to ensure food security and sustainable land management. I'll give you an even more tangible example as a farmer, right? I come from India. India is not energy self-sufficient, imports a lot of fuel, which is actually a topic of conversation now today, right? Every time the fuel prices go up, food prices go up. Those food price increases don't translate into profits for the farmer. The farmer still gets the limited margins that they have access to, but it does put food security at risk. Food security and energy security have now become coupled to each other in many parts of the world, right? Which is why we have to look at them holistically. And that's why that electric and hybrid and other next generation of energy technologies need to go together. The future of farm equipment is very much a combination of digitization, automation, and decarbonization. We have to think about this equipment holistically across all these three, and we cannot break it up and say we'll have a team working on autonomy, we'll have a team working on the digital and smart vehicles, and we'll have another team working on the electric side of things. Because that's not what the next generation of companies that are coming out of Asia are doing. They're all focused on what operation needs to happen, what is the most efficient way to do it, what should the vehicle platform look like from a software standpoint, first, software defined, what is the technology capable of, and then we'll design the hardware. Completely different approach, right? So what we had done at Monarch also, because of our background, was very much similar. We were the first commercially deployed software-defined electric tractor. Today we have lots of data, the second part of it, hundreds of thousands of hours of real-world operating hours, and we still collect all of that data. We're commercially deployed, and unless you're commercially deployed, sometimes the feedback gets obfuscated. You cannot really get to true unit economics unless sometimes you have that commercial validation. And again, are we delivering productivity or not at a tractor level? And this is the money slide here, right? At the end of the day, when we talk about software-defined vehicle platforms, very often what gets confused is we confuse software-defined vehicles with connectivity. If your vehicle is connected, that doesn't make it software-defined vehicle. If your vehicle has telematics, still not software-defined. If you can do an OTA and change a few things on the tractor, still not software-defined. Did you start the design process of that vehicle with what the technology is capable of, and then go to the hardware layer, software-defined, or did we do it the other way around, where we took a platform that we have, and then we tried to put smarts on it? There is a huge advantage in doing it the other way, which is what we already have seen in the automotive side, right? That is one lesson, is some of the automotive OEMs are now learning that the software-defined platforms there's a completely different philosophy of how you design and develop vehicles. The greatest example of that is Volkswagen's $5 billion joint venture with Rivian. Volkswagen as an entity is worth only $50 billion. They spent $5 billion of that on a joint venture with Rivian for software. Why? It's not about technology. It's about the philosophy of how do we develop software and how do we develop these vehicles. And today, Rivian software is going to end up, this is publicly known, is going to end up on everything from a Lamborghini to a Volkswagen Golf. There's a different philosophy of how we develop software, and that's what has to happen from that realm, right? So what is needed also from an autonomy standpoint is, unless we have a software-defined vehicle that is collecting data, I talked about the importance of deployment. For us, it takes around 6 to 8 months. We went to the first dairy farm, and we did 2 dairy farms. We figured out how to do autonomy in dairy farm feed pushing. We trained all of the models. We got it working really well. Farmer was happy. We were like, yep, we made it, right? We scaled to 20, figured out a whole host of issues, and then we had to make changes on the software layer again. The only reason we were able to do it across multiple states and multiple farms is because our vehicle had this capability where we could push the software down and change the operation completely. The second part of it is the data that we collect. The more data that we have, the better off our models will be, and the better quality and efficiency that we'll get out of it. And since it's a work vehicle, our farmers were not willing to accept anything that is lower efficiency or lower quality than what a human operator can do. So you have to meet that bar or beat it, or prove it to them that you are beating that bar. The only way to do that is with data collection, which is where the second layer is. The second layer is the Monarch One cloud infrastructure. All of this data from the vehicles now gets collected, goes into the cloud infrastructure, into an integrated data lake. The reason I use the word integrated is it's a combination of device data, which is tractor data. What is the tractor doing? Speed. What are the different parameters, et cetera. Operations data. What operation are we doing? Even a simple thing like feed pushing, like is the blade up or down? how many feet away are we from the edge of the thing? How much volume is there of feed in the lane? These are all operational data. And then the third one is environment data. Environment data is what exactly is happening on the farm. Did they open the gates? The gates closed? Where is different parts of the equipment located, et cetera? All of this has to be integrated, and your models have to take all of this into account, not just the device data or the operation data, in a combined way for us to train our models and then deploy that back down to the device. Because if you're not able to close this complete loop, we're only going to get portions of this operational quality and efficiency, and then the farmer is going to be unhappy and going to stop using your product. So it's that integrated data lakes. And on top of that sits the fun things that we all like to talk about, which is the AI models, right? These things are great. You still have to have good AI models, yes, but the underlying is what's your deployment look like and what does your data lake look like? And then once you've trained it, can you actually push it back down to the machine again and see whether it's worked or not? And how quickly can you do it? I'll give you an example, right? And this is probably not a great example, and I'm glad my lawyers are not listening because, our AI killed a cow recently. Okay? Did we run into it? Absolutely not. Did we touch it? Nope, did not even touch the cow. So what happened? So we have a feed push blade in the front of our tractor that actually we lower and then we use it to push the feed, right? We have worked on 60 plus farms. We have close to thousands of hours, right, of this feed pushing operation. And we are trying to increase the speed, trying to get the efficiency up. So we are like, how quickly can we lower the blade as soon as we see the feed and push it? And then, we lowered the blade super hard. The blade came down, made a clanking noise. The small calf got startled, got up, tried to run away, hit a pole. Not a good outcome. Within 2 weeks, we had to change our model, the full operational model, not just the device control of what is the blade doing up or down, but what does that do to our tractor, speed, what happens when we see the feed. We had to take all of that data into account, come up with new models, push that down to our fleet of 60 plus tractors on different farms that are doing this same operation. And more importantly, provide all the diagnostics information back to the farmer to explain to them what really happened. That's the challenge of being in a commercial field. And you got to do it at scale, which means it's not just the cost of your technology, it's not just the cost of our tractor and our sensors, it's also the cost of, one, deployment. How are you going to collect this data? How are you going to, you've trained the farmers, et cetera. And number 3, cost of continued service. It's easy to add 4 more sensors and collect that data. Who's going to pay for that? Who's going to pay for your Starlink connection on each and every machine? Who's going to pay for the AWS cost and the cost of retraining these models and all of that? So cost of hardware, number 1. Number 2, cost of deployment, which is going out there, doing the initial mapping, training the farmer, training their workforce, right? Putting all the operational changes that need to happen. And number 3 is cost of continued service. And all those 3 have to be viable for us to do this at scale, in totality. So when somebody says, is autonomy working and what is the cost of your system, those are the 3 questions to ask. Otherwise, you're basically buying the phone without finding out what your data plan is and how many minutes you have and how long your contract is, right? So those 3 are super important, and that's where we are seeing the focus from not only the farmers, but also the OEMs today. So I got to speed up, I got to time up thing. And that's where it's super important from a legislative standpoint is when I was in China, the government basically said, hey, we are going to outdevelop you guys. And I was like, and they said, you need to partner with us just for the data and deployment side. I was like, what are you talking about? Why do you think you can outdevelop us, right? And they said, well, we're going to put more machines out there that are subsidized by our government. Our government has already agreed to it. We're going to build these machines. We're going to go out there even if the technology is not 100% ready. We're going to collect more data than you, faster than you, train our models better, and we'll be out there. We've done this in automotive. We know how this model works. We've been successful. We're going to rinse and repeat that in our next generation of farm equipment. So here's my question to all of us. Are we willing to let the same scenarios play out that we have seen in other industries Are we willing to have our data, our smart equipment, come from a different source? We just talked about how DJI drones have been banned. Do we want to get to that scenario where we are banning equipment from other parts of the world? And when we talked to them about, hey, we're going to put all this data, they said, oh, by the way, you cannot move your data out of China. We said, no, but we'll put all the, the compliance regulations and all that. We're not going to share this data. They were like, no. Our food security data is not going to leave the country. The data that comes off of our machines or what's happening on our farms is not going to leave the country. So we need you to take that whole infrastructure, replicate it in China. We were like, okay, that's possible, right? We're going to use AWS, China, blah, blah, blah. And they were like, no, can't even sit on any US-controlled entity data. So the cloud infrastructure and even the chips, we want to have a roadmap of how we can move this over to locally produced chips. So that's how they're treating their food security. Are we having those level of conversations here is my question. Do we have that level of support to get these machines into farmers' hands so that we can all collect that data, so that we can make our models better, so that we can make our machines better and deploy that is the other question. And this doesn't require hundreds of millions of dollars, but it does require commitment from everybody from the government policy work down to OEMs, down to technology providers. And what we have done at Monarch is to prove that we don't need to do all of this individually across 400 different OEMs, right? Is one of our key partnerships that we just announced at Farm Progress is with AGI augers. We took that same platform that we developed for our tractor, and we worked with AGI, and within 5 months showcased a platform that is smart, electric, and automated. The farmer can now control this auger, does not even look like a tractor, from the pickup truck. The same cameras can recognize these things. The AI models have now been trained on where and how much feed is in the truck, when should we start, stop, etc. And now we're now connecting that to the grain silos, right? So again, the platforms now need to be scalable, and we need to think about this as now we've turned an auger into a software-defined vehicle. And as AGI is coming up with new use cases for their farmers, we are continuing to push out these apps down, which is where the farmers see the value. And that's what the story is about, right? The story is all about unit economics, which is what is the cost of the hardware, what is the cost of deployment, and what is the cost of continued service. And that totality has to make sense from a farming standpoint and from an economic standpoint. And that's what we have done at Monarch, right? This is the last slide. What we have done is we have taken all of the lessons that we have learned on building machines, deploying machines, collecting data on 4 different continents, right? How do we service these machines, et cetera, et cetera, et cetera. And now we have turned that into a platform called Monarch One. We are working with global OEMs. We are working with governments. And in India, we're talking about a sovereign cloud that's going to sit in India. In Europe, we're talking about a sovereign cloud that's going to sit in Europe. Somebody talked about Starlink, right? I talked to the Europeans, and they were like, what if they decide to turn off Starlink like you guys did in Ukraine, right? It's like, fuck, right? So we want our own satellite service. We want our own cloud infrastructure. So that's where the world is headed. So all of us now have to think about this in those terms and think about scalable platforms that we can deploy. And it doesn't need to be a lift that all of us do individually, but we all need to get together and do it together, right? So again, I'm here to change perspectives from the government side, from the OE side, from the technology side. If you have any other questions, I'll be available, or reach out to me, right? Happy to talk more. But we at Monarch are very much focused on building this future in such a way that we don't have to mortgage our food security just to make our farmers profitable. Both of them need to happen. And both are needed. Thanks.